guys, and welcome to Mindset Learn's Spring School. Finally, I couldn't wait.
Finally,
Tamlin.
we're here.
I'm telling you, I could hardly sleep last night. I was so excited about today.
Well, I hope you learn a lot today then.
I'm going to. And a little birdie told me we're going over calculus today.
We are indeed. You guys have already had a bit of background on it, so now what we're going to do is just consolidate everything that you guys have already had a look at and hopefully sort out any problems that there are.
Exactly, and this is what Spring School's about. It's about that one last push. Finals are around the corner, and guys, we are really, really here to help you out.
Absolutely,
yeah.
for sure.
So, Tamlin, take your spot by the board.
So
I'll
much.
do the usual. Okay, guys, today is very exciting. Join us on facebook.com/learnextra. Also, chat to me, Indy, on Twitter, @LearnExtra. We are here to help you with all of the questions that you've been wondering about. If Tamlin's going over something and you don't understand, please, now is the time to pop it onto our page. Let us know so we can answer those questions. The only silly question is the question that is asked after the exam. And guys, let's get this all done. Finals are just around the corner. So now I just need to tell you a little bit of a thing of what we're doing today. We are running a challenge question today. We do have a Spring School challenge question tab on our Facebook page. I will be posting the link to it now. You can go and see if you can have a look there and find it. There are other ways to enter this competition too, and what you will be winning, I just want to show you here quickly, is this awesome t-shirt. Check it out. I'm a mindsetter. And this awesome study note. So this is mathematics, grade 12, and a CD, which we'll be posting onto the page a little bit later. I will be posting that link. So keep watching the page. And I think what we're going to do is we're going to go over to Tamlin, start the lesson, start chatting to me, and we're going to have an awesome, awesome Spring School. Big up to Liberty for making this possible. You guys rock. Now let's have a fun day. Let's have an exciting day. And let's start with calculus. Tamlin, take it away.
Thanks, Indy. Hi, guys. Okay, what we're going to do this morning is we're actually going to start by having a look at that challenge question. We're not going to answer it just yet. I'm going to show you what it's about, and then you guys are going to go and sort that out and figure it out. What the question has asked us to do is the derivative function of f is f dash x equals x squared plus 2x minus 3. For which values of x does the function f have a turning point that is a local minimum? Okay, so you guys are going to go and dig deep into your theory of calculus there. Consider what a turning point is. When we talk about calculus, when we talk about local maximums and local minimums, what are we doing with that? Okay, see if you guys can figure out for me which of those three values for x is the one where there is a local minimum. Okay, right, good luck. I hope you guys will manage that well. Right, we are going to get going. As we said, you guys have now had a bit of introduction to all the concepts of algebra. You've had a look at derivatives, you've looked at first principles, and then after that, graphs and also calculus application. So what I'm going to do for you guys today is just round it all up, package it all together, and hopefully really send you all feeling like you're understanding the concepts and the theory behind what calculus is all about. So let's start with this. I'm going to actually start by asking you a question. When we work with derivative, okay, calculus is all about this word derivative. And what tends to happen is that we land up using it so much that you actually forget what the root of the word derivative actually means. What is it all about, okay? So this is what we're going to start off by doing. I hope you have a pen in front of you. You're going to write this down for me. And this is the first thing I want you to remember when you are working with calculus. Derivative means we are looking for the gradient of your tangent. And another way to phrase that is that we're looking for the rate of change at one specific point, okay? In the previous show that was on a bit earlier, you spoke about average gradient, which was between two separate points, and you're working out the average gradient, just doing your normal change in y over change in x. But with derivative, what we're doing is working out that gradient, but at one point. At 1 point, and that's really important to remember. Right, guys, typical question that you're going to be faced with as one of the first questions in your calculus paper is to calculate that derivative by means of first principles. Okay, so let's go through it carefully. This is worth a good 5 or so marks, and you know what? It's actually pretty easy to get as long as you have your steps all in line and you understand what's going on. Okay. Right, we're looking for the derivative of our f of x function. Here's our f of x function, which is 9 minus x squared, and what we are looking for is the derivative. So the first thing we're going to do is we are going to write down our first principles formula, which is f of x is equal to our limit, where h is tending towards naught, and we have f of x plus h minus f of x all over h. All over h. Okay. Please always start by writing that formula down. It also just helps you to take a second to just get your head clear and know exactly where it is that you're needing to go. Very important to have that sort of clarity and just calm about yourself when you're doing this. Okay. Let's just quickly write above here. F of x, they've told me, is 9 minus x squared. So what we need to do is establish then, what would f of x plus h be? Sorry, that's a funny h. Okay. What would f of x plus h be? If I'm taking this x value and I'm replacing it with an x plus h, then we're taking that original function of 9 minus x squared, and everywhere you see an x, you are going to replace it now with the bracket of x plus h, okay? So I'm going to write 9 minus, but instead of x, I'm replacing it with x plus h, and it is being squared. So that's the value of f of x plus h. So when we work with our f of x plus h in our formula, we are going to be working with the 9 minus bracket x plus h squared. Okay. Right, so into our equation. Now remember with calculus, we're very, very sticky about how we write our sort of our notation. So we start by saying equals limits h tends to naught. You keep writing that limit. I know you know that by now, but I will tell you when you can stop writing limit, okay? So f of x plus h was the value of 9 minus x plus h squared minus the value of f of x. Remember, the value of f of x was our original function. So therefore, in a bracket, 9 minus x squared. Why in a bracket? Because the negative is going to distribute into your bracket, okay? And it is over our h, just h, okay? Right, so that's the first step done. Now it's a case of doing a bit of tidying up. So I keep my limit. I've got my h tending towards naught. And we're now going to, first of all, FOIL this bracket out. So we're going to have x squared plus 2xh plus h squared. And I'm going to distribute the negative into that bracket. So negative 9 plus x squared. And again, it's all over our h. All over h. Okay, we're not quite done with tidying it up just yet, so we're going to take another step to do so, and we keep writing our limit h tending towards naught. Okay. Right, next thing that's going to have to happen is that my negative will need to distribute into the bracket, so therefore I've got 9 minus x squared minus 2xh and minus h squared. I've got a minus 9 and a plus x squared. And again, we're still sitting with everything over h. Okay. At this point over here, grade 12s, you actually have a nice checkpoint for yourself. If something is sitting without an h, it is going to cancel, okay? And if it doesn't cancel, please go back and check your working out, because somewhere in there an error has been made. So everything without an x needs to cancel out, okay? Now this is going to work nicely because plus 9 and minus 9 cancel each other out. Negative x squared and positive x squared cancel each other out. And everything else that we are left with has an h. So that's how we know, okay, we're looking good, that's fine. Now we are going to want to now see if we can get rid of our denominator of h. But remember, what we need to do with this limit is we substitute the limit into your equation. So essentially everywhere we are seeing an h, we are now replacing it with naught. But there's a problem there, okay? Because if I were to just substitute naught into h as it stands at the moment, you would be getting a denominator of 0, okay? Denominator of 0 is undefined. We cannot work with that. So we need to somehow try and get rid of the h at the bottom. And as far as first principles goes, grade 12, this is your standard method. This is what we do. We are going to, first of all, still keeping our limit where h is tending towards naught. You are going to take out h as a common factor. Please just take out h. Even if there are other common values, don't take out anything other than the h. And the reason for that is because we only actually want to cancel the h on the top with the h on the bottom. It's not necessary for any other common factors. So therefore, your two h's cancel each other out. And we are sitting with, let's just write this one more time, our h is tending towards naught. And we've got negative 2x minus h. It is at this step, grade 12, that we are now allowed to substitute our h with 0, okay? And by doing so, that will give us our derivative. So therefore, our derivative is equal to negative 2x. And if I said minus naught, obviously it would just fall away. So that is the derivative of our original function, which is just negative 2x. What does the derivative stand for again? It represents the gradient at a point. Okay, so that is what that little negative 2x is actually doing, is helping us to calculate any kind of rate of change at a specific point for that function. Okay, right, I hope you guys will remember that. I hope first principles is clear to you guys. You will definitely be getting one of those in your finals, and they're worth some pretty good marks, so it's worth practicing them. Right. Once you have done your first principles, you are definitely also going to have to find the derivative, but not by first principles, by using your rules of differentiation, okay? So this is saying, okay, we know these rules, which I'm going to go over with you in a second, and we've got to apply them to find our derivative. We don't need the whole limit x tending towards naught, h tending towards naught, because that is not necessary. That's first principles, okay? Right, before we get going with an actual example, let's just talk about what we're doing when we're using our rules of differentiation, okay? There are a few conditions that you need to remember in order to apply your rules, okay? And the first condition is this. If you are sitting with a variable in your denominator, so if you're finding the derivative in terms of x, then x would be the variable that you're looking at. You may not have the variable in the denominator of your fraction, okay? So you cannot find the derivative until you have brought that variable up, okay? What we're doing there is applying a few rules of exponents. If I were to bring my denominator up, it would then become x to the negative 1. As soon as it's up at the top, then it's fine. Then you are able to work out your derivative, no problem. The other thing to please watch out for is that if you are working with a surd, a square root, a cube root, any root, if it's a surd, you also may not leave it in surd form. We have to get it out of surd form. Now, just to remind you, let's say I've got just a plain little x inside a square root sign. The rule here is that the exponent of my x is in a little invisible 1, and this essentially is a square root. We never actually write that to, but we know that it's there, okay? And what we do to get it out of surd form is I take my x to the power of 1 and we divide the exponents by the root. Okay, so the square root of x would then become x to the half. Now, please remember, you cannot apply your rules until you have sorted out anything in your sum that looks like that. Okay, that's really important to remember. Okay, so let's have a look at an example and let's see what we can do with this. They've given us d of x, and we've got 1 plus 6 root x, okay? The notation d of x is saying calculate the derivative in terms of x, okay? And this is what we've got. As it stands, I am not ready to find the derivative. And why? Because I'm sitting with a surd, okay? What do we do with that surd? We take it from its surd form and we write it, we apply our rule where we write the exponent divided by the root, okay? So I'm going to keep my d of x over there. The reason still is because I'm still saying find the derivative of x. I'm not finding the derivative yet. All I'm doing is getting it into a form where I'm ready to find the derivative, okay? So I've got 1 plus 6, and that will become x to the half, okay? Right, let's look at it. I've got a whole number of 1. Okay, that's not a problem. There's no reason to have a problem with that. I've got a 6x to the half. Right, I am now ready, grade 12, to actually apply my rules, my differentiation rules, okay? And those would be, let's just take a quick example over here. If I had 2x to the 4, the rule is we take our exponent, we multiply it by the coefficient, the number in front of the variable, and that in this case would be 8. And then remember, you always subtract 1 from your exponent. So that would be 8x cubed as an example. Okay, so let's look what we've got here. Now, because we are actually ready to find the derivative, we no longer need to write dx anymore. We just write equals, because this is the derivative that we are finding. A whole number, if it doesn't have an x on it, when you are working with the derivative, it will fall away. Okay, so 1 will fall away. And I am going to multiply 6 by a half, which is going to end up giving me 3. I then have got my x, and I'm going to subtract 1 from a half, which is going to leave me with negative a half. Okay? We don't like leaving our exponents as negative, so what we are then going to do is to take our 3. We leave our 3 where it is, because that's not raised to a negative exponent. The x is what's being raised to our negative exponent, so that comes down to the bottom. And finally, what we can then do is put it back into surd form. So we can say that it's 3 over root x. Okay. Right, grade 12s, I do have another example that I want to go over with you, but we're going to take a very short break. I hope you guys are still thinking about your challenge question. And just think about the rules over here for a minute, because when we get back, we're going to try another one, okay?
Okay, perfect. Okay, guys, about that challenge question, it will be on again during the break, and there are many ways you can do it. Either you can answer it on our events page or on our Facebook page, or you can SMS the answer to 083 44 888 10. And don't forget the code, guys. The code is very, very important. You can also enter on our pep text group, and the groups is Learn Extra, and you can also email us win@learnextra.co.za. So there are many ways to win this awesome prize. And what we're going to do is we're going to take a quick break, and we'll see you now when we get back. Hi guys, and welcome back. It is spring school and we are having such fun. I just wanted to let you guys know, because you asked for it. You said, please can we replay these shows at night? So that's exactly what we will be doing. Today's shows will be playing again tonight. So if you're watching today and you need a little bit of a catch up, you can watch again. And then another thing is, we've got our spring school books. If you haven't gotten yours yet, no need to worry. You can still download them from our website. And I have put them up onto the Facebook page. But just in case you need the website now, it's www.mindset.co.za/learn/extra/spring school. So that's exactly where you can go and get these spring school books. You can download them and work along with the teachers. So now before we get started, I just want to say a big up to all of our grade 12 mindsetters that have joined in. I know we've got Luvuyo is joining in, Nare, Justin Naidu, you're watching, and I'm so glad that you guys are all joining in. Also the Sia Demors and the nieces and the Takalanis. Guys, you rock, and your guys are going to fly through these finals like you have no idea. So what I'm going to do now is I'm going to pass you back to Tamlin. Tamlin, take it away.
Thank you very much. Right, I hope you've had a moment to go over that, have a look at it, and let's give another one a try. Okay. I really like this question, and the reason why is because I know a lot of you guys you battle to get this right. Okay, so what we're going to show you is a method to apply when you're showing your rules of differentiation here. And guys, do it every time you see a question like this. Okay, so listen carefully to how we're going to identify this question. I have got more than one term on top. Okay, so in this particular example, I've got 2 terms in your numerator, and you only have 1 term in the denominator. And that's how I want you to identify this type of question. And it's really common, okay? We like to ask this question. This denominator is only 1 term. Now, I find that everybody has a bit of a hard time understanding what to do with that denominator. Okay, this is what you are going to do. I want you, now do you notice I'm writing y still? I am not finding the derivative. I'm just tidying it up. Remember, the problem at the moment is that I've got an x in the denominator, and we're not allowed that, okay? So we need to just tidy this up. And what we are going to do, guys, is I'm going to separate that denominator of x to the 5, and I'm going to give each term in my numerator its own denominator. Okay, so can everybody clearly see what I've done there? I've taken each term on top, and I've split it, and I've given each of them their own denominator, all right? I'm still not ready to find the derivative, so I'm keeping it as y equals. We're not applying any rules of differentiation at the moment, okay? So we're not doing that yet. We are tidying up, right? I've got an 8 on the top and an 8 on the bottom, which cancels, and that leaves me with 1 over x to the 5. Our problem, guys, is that an x to the 5 is at the bottom, and we cannot have that, so we're going to bring it up. And it's going to then become x to the negative 5. I've got negative 3 over 8, which is not going to cancel or simplify, so I'm going to leave it as is. And if I've got x to the 6 over x to the 5, okay, rules of exponents, when I'm dividing bases, I subtract my exponents. So 6 minus 5 is going to leave you with just x to the 1. Okay. As it stands now, we now are not being stopped by any kind of problem where there's a denominator of x or there's any kind of surd. We are now allowed to go ahead and work out the derivative. So it's at this point that we can now use our notation of dy over dx. Okay, the derivative of y in terms of x. Right, the rule, if I multiply negative 5 to the front, I'm going to get negative 5x. And remember, we subtract 1 from our exponent, leaving us with negative 6. The invisible 1 sitting above your x over there is going to multiply to the front, and anything multiplied by 1 just stays as it is. But if I subtracted 1 from my exponent, I land up with x to the 0, and anything to the power of 0 is actually 1, okay? So as a result, we don't write that 1. It's not necessary. So therefore, that would be your derivative. I'm not completely done yet because I don't want to leave my exponent as negative. So therefore, just a final step, just to make sure that we're not leaving any stones unturned, is that my 6 goes down to the bottom again, and that's 3 over 8. What does that represent again, grade 12s? I'm going to drum it. Your derivative, that derivative represents the rate of change at 1 point for that function. Okay, and that's what we are doing when we work out the derivative. Okay.
Tamden, can I ask a quick question?
Yes.
Okay, so this is from Mindset to Sidonia, and she's always on the page and she's always interacting, which is awesome. And she asks, our teacher always says, remember to rationalize the answer. Please, can you explain that?
Okay, rationalizing is where you have a root in the denominator. So if I had 1 over root 3, that would be non-rationalized, okay? So rationalizing it means taking it from the root in the denominator and getting rid of that root. Now, the only way that you would get rid of a square root such as that is to actually multiply it by itself, okay? So if I took root 3 and I multiply it by itself, okay? We can do that, but there's a condition here, and that is what you do to the bottom, you must do to the top. So therefore, I multiply that by root 3 as well. Okay, oopsie, I jumped over. So what are we left with then is that 1 multiplied by root 3 is root 3. And root 3 times root 3, whenever you multiply a root by itself, basically what happens is your root falls away, and the number that was there is what's left. So therefore, root 3 times root 3 is just 3. And that would then take it from a non-rationalized to a rationalized fraction. And that's what we're doing, as that would be your answer to rationalized. I hope that helps. That's what the answer to the question should be.
I'm sure, Sidonia, if you do have any other questions, guys, please post them onto our page. This is the time that we can answer those questions. And please don't think that they're silly, and you never know. This community is for you. You might post a question, and another mindset will actually help you answer it. And I think it's good. Yeah, ask away.
Absolutely, always. It's the only way you guys will actually get your head around it, so always, always ask. Okay, guys, another question which I can guarantee in some form or another is going to be in that paper, and it's our cubic function. Okay, so let's have a look at this. Lots of theory behind this. I'm going to just fill in lots of gaps here, and let's see what we can do with this question over here. What they've given us is they've given us an f of x function, but what you'll notice straight away is that they have not actually given me the equation. They've given it to me in just standard form, okay? So that's the function f of x. The function of g of x, they've told me, is 6x minus 6. Okay, so that's fine. We know that equation over there. They've told me that point A is the point negative 1 and 0. They have told me that point C is 3 and 0. And that point D is 0 and negative 6. Okay, just to be aware, obviously that over there is an x-intercept, and this over here is an x-intercept. And in fact, this over here is a y-intercept. Okay? All right, so the idea here is that we need to use the information that they've given us, and we need to actually work out the equation of that cubic function, okay? Now, there is actually a very standard way in which to go about doing it. So if we learn these little bits and pieces of theory, it makes your life a lot easier, grade 12s, okay? If you have been given your x-intercepts, and do you guys agree that looking at my diagram, I've been given my x-intercepts. I want you to start with the standard formula being this. Okay, we're going to start with y equals a. I want you to take x minus x1, which represents your first x-intercept, x minus x2, which is your second x-intercept, and x minus x3, which is obviously your third x-intercept. And we're going to sub them in. But now I'm sure I can hear you guys asking, but hang on a second, there's only 2 x-intercepts, so where is this third one supposed to come from? Okay, right, next bit of big NB note that you're going to put next to this, please, is that if you have got a turning point, that is, can you see that point over there is bouncing off your x-axis, okay? That point is doubling up as an x-intercept and a turning point, all right? And if you ever have a point that is doubling as an x-intercept and a turning point, when we use our formula, when we use this formula, we actually substitute that value for x in twice, okay? So that's what you've always got to remember there. So therefore what we are going to have is I've got y equals a. I've got x. Now remember, this x-intercept was negative 1. So when we substitute it back into the formula, because there's already a negative there, it becomes positive 1. And I do it again because remember I said that it's doubled up as a turning point and an x-intercept, so we square it. And x minus 3, that was the other x-intercept. Okay, so that looks good, except I'm still sitting with the problem that I've got variables of x, y, and a. Okay, so there's too many variables over there. But what we can do is let's go back to our graph and let's find another point sitting on your graph, okay? And do you guys see that I do have another point sitting on that line, which is the x value of 0 and the y value of negative 6. And that is what we are going to do. We are going to substitute y with negative 6. And everywhere you see an x, you are going to sub it with 0. All the x's that you see. Okay. And let's simplify. What do we get? So I get negative 6 equals a. I've got a 1. 0 plus 1 is 1. 0 plus 1 is 1. And that's negative 3. Okay, so that gives us negative 6 is equal to, that's all going to simplify to negative 3a. And the way we are going to get a on its own is we will divide by negative 3. That's giving me 2 is equal to a. Now what's great about this question is that I can now see that I've achieved the first variable. I've now found what they wanted me to find in the beginning. What do we do now to find the other variables? Okay, we go back to what we have just worked out and say, right, in the formula y was equal to a, I had a bracket of x plus 1. And remember, there were 2 of them, so I'm going to say squared. And then we had an x minus 3. Now, we have just worked out that a is actually 2. And I've got x plus 1 squared and an x minus 3. Your job now is to now take that and FOIL it out and distribute it out and simplify it out. And once you've done that, you will very easily be able to identify what your B, your C, and your D value are. Okay, simplifying this out, please be careful with your order of operations. You are not allowed to distribute the 2 until you have done your squared, okay? Just a silly mistake that you might do in a moment of rushing. Watch your order of operations. So we've got y is equal to, I've got 2, and I'm going to FOIL my bracket out. Just to point out another quick mistake, guys. If you have got a squared on top of a binomial, you are not allowed to just square and square. Okay, that is a big, big, major no-no. You've got to take the bracket and FOIL it, okay? Right, x squared plus 2x plus 1, that's what it would be when we FOIL it out. and we've got our x minus 3. So now it's a bit of a tedious process, but we are going to have to distribute. My x is going to have to multiply to all three terms, and my negative 3 will multiply to all three terms. So we land up with y is equal to 2. I've got x cubed minus 2x squared plus x. I then have minus 3x squared. I have m minus 6x, and I've got m minus 3. Let's tidy it up. So my 2 is here. I've got an x cubed where there are no other x cubed, so that's going to stay as is. Negative 2 and negative 3, I'm going to get a negative 5x squared. I've got a 1x minus a 6x, which is going to give me a minus 5x. And I have got minus 3. Okay, I hope that's all fine. Sometimes you make these little errors. Y is equal to 2x cubed minus 10x squared. Let's just double check here that we've got minus 10x minus 6. Okay, let's just go back and check. What did they want? We wanted a b value of negative 2. Remember, b was the value that's in front of your x squared. Okay, we've made a small mistake somewhere over there. I'll have to go back and double check where we've made that mistake. The c value did work out as negative 10, and our d value worked out as negative 6. Okay, we got negative 6 down there. Okay, obviously somewhere in the multiplication there I made a small mistake with multiplying out, but we are supposed to land up with negative 2 there. Go ahead and do it yourself, please. See if you can make sure you do get that value and make sure that we get that right. More importantly, though, the method. Okay, you guys can see the method, you can see how to apply it, and that is how you are going to go about doing it when you have your when you have a cubic function that you have to find the equation of. Okay, if you know the method, that's it. Just go ahead and apply it.
Okay, so let's take a little break. Guys, this gives you a chance to go and get something to eat, something to drink, just relax and get those questions coming through. If there's anything you have been wondering, please post it onto our Facebook page. That's facebook.com/learnextra. Or you can even chat to me on Twitter @LearnExtra, and we are here to take all of those questions and help you out. Don't forget that the challenge question is on. You will be seeing that question during the break, and we'll see you now. Hi guys, and welcome back to Spring School. I hope that you are enjoying our first live session as much as we are. We're having an awesome time, and you guys are rocking it on the events page with the competitions question, and we've got lots of answers that are coming through thick and fast. So now, just in case you missed that out, if you saw the challenge question during the break, hopefully you are working on it, and I just want to let you know what the prizes are for that awesome competitions question. So you're going to be winning this awesome I'm a Mind set of t-shirts, exactly the same as the one I'm wearing, this awesome mathematics grade 12 book, and then this is where things also start getting exciting. We've got some CDs for you, not one, not two, but 3 CDs that we are giving away to today's winner in this session. And let me tell you what they are. There's Electro Candy, number 4, which is Soul Candy CD. Very, very cool. And this one is a platinum edition. This is Mikasa. I know how much you guys like grooving down to Mikasa. And then we've got the Workout Mix London 2012, and that's got, it's got Rihanna, it's got Jessie J, LMFO, Lady Gaga, all of the nice ones. So that's what you get for answering our challenge question, guys, and learning more and learning extra. Please join us on facebook.com/learnextra. Also chat to us on Twitter @learnextra. And this community is for you guys. Please, if you see somebody that has asked a question on the page and you know the answer, please help them out with the question. This community is for all of us to learn more and learn extra. And I think what we're going to do is we're going to go straight back to Tamlin. Tamlin has figured out where we went wrong, and we'll be showing you how to fix those mistakes. And always remember to breathe during the exams, guys, and just relax, and you can do this.
Absolutely. Okay, right. Just to point out where we made the error, we have put our little smiley face over there. There's the problem. We were supposed to distribute a positive 2x times by another positive was supposed to be positive 2x squared, and that was where we went a little bit off course. So I know, practice what we preach. Be very careful with your distribution. Be very careful with your signs. Obviously, small errors can land up in big mistakes, so we've got to watch out for that. Okay, guys, let's move on and see what it is the next thing that they want us to do here. They are now asking us to calculate the coordinates of the turning point. Another word, do you guys remember, another way we can phrase the turning point in calculus is to refer to it as the stationary point. Okay, the reason why we call it the stationary point, just to give you a bit of background, remember the derivative represents the gradient of your tangent. Now, if I were to take a tangent and actually draw a tangent at the turning point, all right, what do we notice about the gradient of that line? It's a horizontal line, and a horizontal line will have a gradient of 0. Okay, so why do we make the derivative equal to 0 at our turning points? That's why, because the tangent at your turning points is equal to 0. The gradient of your tangent is equal to 0. All right, so that's what we're going to go ahead and do. And we need to use what we've just found. So we worked out that we had y was equal to 2x squared minus 2x minus 10x minus 6. And I'm just going to double check that that is the right numbers. We had negative 2, negative 10, and negative 6. Okay, that looks fine. All right, so that's the function that we have now just worked out, okay? And now what we are going to do is find the derivative. So we're going to put our dy over dx. And in fact, what we're actually going to write here is let the dy over dx equal 0, okay? So therefore, we are going to let our derivative, which is 4x, minus, hang on, that's supposed to be cubed, that's squared. Okay, let's just fix that. Okay, right, so we've got 6x squared minus 4x minus 10, and we are letting that equal 0 because that's what we do when we're working out our stationary points. At this point over here, let's take out our highest common factor, which is going to be 2. So we're going to be left with 3x squared minus 2x and minus 5, okay? Factors of 3, factors of 5, we're looking for the value of 2, okay? If I take my values, my 1 and my 5, my 3 and my 1, we are going to get a 2. So therefore, I've got a 1 and a 5. I'm going to put my x. I've got my 3x and I've got my 1. And we're going to need a negative 2, so therefore the minus will have to go into the 5 and the plus into the next bracket there, giving us x is equal to 5 or x is equal to negative a third, okay? And that means that our turning point, obviously b is not negative, it's positive, all right? So therefore this point over here, we are going to have the x coordinate of 5, the y coordinate we are going to have to work out. And by doing so, we would substitute the value of 5 into each of the x coordinates. But please remember that it always goes back into the original function. Okay, so you take your value for x, do not sub it back into the derivative. Okay, that would be working out a completely different thing. That would be working out the rate of change at the point where x is equal to 5. And in fact, you would land up with 0 because it's at the turning point. So we sub it back into the original function, okay? So therefore, we substitute f of 5 into my original. So I had 2, I then have got 5 cubed, I've got minus 2 times by 5 squared, I had minus 10 times by 5, and I had minus 6, okay. All right, I don't have the calculator in front of me just at the moment, so I'm going to let you guys take a moment and work that one out. And what you can do is let Indy know what the answer is, and I will tell you if it is correct. Okay, all right. And in the meantime, I will move on to the next question. Okay, we are still looking at the same function, okay. But what we are now going to do is this. And this is also a very common question. Again, there's a method to it, guys. So if we learn the method, if we're familiar with the question and the method, this is very doable, okay? What they have said to us, and this initially the write-up looks quite confusing, but if you just read it carefully and then interpret what they're asking is a lot less complicated than what it looks over here. They've said h of x is the vertical distance between f of x and g of x. That is, h of x is equal to f of x minus g of x. And they're asking us to calculate x such that h of x is a maximum where x is less than 0. Right, let's now put that into English in terms of what we're actually wanting from you guys here. Okay. We're taking a line h of x, and h of x is between where my f of x minus my g of x is lying between the two graphs, okay? So essentially what we're doing is we're looking at a vertical line between my two graphs, okay? Now, essentially this is it. There's a point of intersection over here. I should make that green. There's a point of intersection there and a point of intersection here. The question did specify that we're looking for all the values less than x. So therefore, we're looking only on the negative side of my x-axis, okay? That was stated. The idea, grade 12s, is this. If I were to take this line and move it left or move it right between the 2 points of intersection, at what point, if I were to make it longer, at what point would this line, that would then start getting a bit shorter, be at a maximum or at a minimum? So do you guys get the idea? That's what we're doing. We're moving it between the two graphs, and we're seeing at which point for x is it at a maximum length, okay? Now, the second you have got any graph interpretation question, and this doesn't have to only apply to calculus, it can apply to your normal function questions as well. If you are looking for the length of a vertical line between two graphs, okay, I want you to start by taking the equation of the top graph minus the equation of the bottom graph, okay? So let's make sure, okay, so let's just write down our equations at the moment. So our f of x equation was 2x cubed minus 2x squared minus 10x minus 6. That was the f of x equation. And our g of x equation, we haven't used that yet, is 6x minus 6. 6x minus 6. Okay, so as the question actually stated, h of x is equal to f of x, which was the top graph, minus g of x, which is the bottom graph. Okay, so therefore, h of x is equal to my top graph, 2x cubed minus 2x squared minus 10x minus 6. Top graph minus the bottom graph. Bottom graph being 6x minus 6. Okay, right, let's tidy that up. So I've got h of x, which is equal to, my negative needs to distribute. So we've got 2x cubed minus 2x squared minus 10x minus 6 minus 6x and plus 6, okay? And let's just tidy up one more time. We need to add like terms. I've got a 2x cubed. I've got a negative 2x squared. Negative 10 and negative 6 is going to get us to negative 16x. And these two are going to cancel each other out, okay? All right, so that is now the equation that represents the length of h of x, all right? Now, to work out the maximum length of h of x, like we do with calculus, what we would need to do is work out the derivative of that h of x function and let it equal to 0. That's what we're doing when we work out maximum and minimum. So we're now going to take the derivative of h of x and say I've got 6x squared, I've got minus 4x minus 16. And we're going to let that h of x, h dash x, equal 0. Okay, so therefore, I have got my naught equal to. Now, in this step, what I'm going to actually do is take out, again, a highest common factor, which is going to be 2, giving me 3x squared minus 2x minus 8. Okay, and we need to factorize this. Okay, so we're looking for factors of 3 and factors of 8 that are going to get us a 2. I can see that if I use the combination of a 6 and a 4, we are going to get that 2. So therefore, I'm going to have a 3x and a 4. I'm going to have a 1x and a 2. The 6 is going to have to be the negative because you want a minus in the middle of your trinomial there, and that will be a plus. Okay, so therefore, what are the two answers for x that we land up with? I get negative 4 over 3, and I get x is equal to 2. Negative 4 over 3 is the same as negative 1 and 1/3, and that, remember, it's stated in the very beginning that x had to be less than 0. So in other words, we were looking for an x value that was negative. So therefore, for which value of x will h of x be a maximum length? At the point where x is negative 1 and 1/3. Okay, so if that's negative 1, essentially it would be slightly on, and that would then give us the longest point of h of x between those 2 points of intersection. Again, guys, that's theory, and I want you guys to please go and practice that. It's very commonly asked, and it applies the same principles, the same methods get applied if you're doing a sum such as that. Okay, so very much a case of just go and practice and learn your theory there. Okay. I hope at this point you guys are all understanding. I hope you're all feeling confident and clear about what we're doing with our calculus so far. It is essential to remember that if you're working with a derivative, you are finding the gradient of a tangent. Okay, and now that's really important for what we have to deal with next over here. They've asked us they've stated that the tangent to the curve of g of x, and they've given us the equation 2x squared, in fact 2x squared plus px squared. Guys, that's going to be a mistake there. Let's just quickly change that to cubed. Okay, that'll need to be cubed. 2x cubed plus px squared plus qx minus 7, and it's at the point where x is equal to 1. So what are they saying there? Your tangent and your cubic function are touching each other at the point where x is equal to 1, and we call that a point of contact. Okay, so that's our point of contact. And the equation of the tangent they've actually given to me over here, quite often it's actually a case of we have to actually find that equation, but if it's given to us, okay, then we'll have to use it. And they've told us it's 5x minus 8. Okay, so first things first, and in your mark allocation, we'll see that this actually was just for 1 mark, so it was very quick and easy working out. They're asking us to show that negative 1 is the point, negative 1 and 3 is the point of contact to the tangent of the tangent and the graph. Right, let me just quickly, okay, that's supposed to be positive 1. Little typos here. Okay, right. We know that. What you've got to remember is that your point of contact touches both your cubic function and your tangent. Okay, so if you have the equation of one of them and not the other, then obviously use the one that you have the equation of, and you would substitute your points into that equation, all right? And obviously the one we have the equation of is your tangent. So let's take that tangent and let's substitute. Now what we know is that x was equal to 1. So therefore, to work out what the y coordinate would be, where x is equal to 1, okay, we substitute it in. And we land up with 5 minus 8, which gives us a y value of negative 3. Okay, so sorry, guys, that was supposed to be negative. Sorry, I think our signs got mixed up when we were having this all transferred on. So we were looking to show the point of 1 and negative 3, and that is what we have managed to do. I'm sure that that's what we were asked to do. Okay. All right, so let's just double check. Does that make sense? Oh, we don't have a diagram. Okay, never mind. Okay. So that's now what we've done. We've proven that point over there. Now what we're going to have to do is use that point to answer the next question. I just want to double check here if I am correct that we actually were right with the substitution. If it was negative, yeah, no, it would definitely
Let's
be.
take a little ad break.
Well,
I think.
okay.
I think that's the best. Okay, guys, I see there's a whole bunch of questions on the page. I will be going through it with Tamna now during the break. It gives us a nice chance to see what's going on the page. It's going crazy. Guys, it's amazing that you're all tuning in. Anissa, how are you? Noxopedia, where are you, Noxie? I think we're trying to find her in Kashifa. We're also asking, where is Kashifa? Hope that you will be joining in later. But guys, we're having such fun, and you guys, please post the pictures. I mean, any pictures you have on the page, any questions, anything you need to know, we are here to help you. See you now after the break. Hi guys, and welcome back to Spring School. We're having an awesome time and the page is going crazy. So I just wanted to read out a few comments and a few questions just before we get started. And I just wanted to let you know that the competition is closing at 10 past 12. So you've got about 12 minutes to get your answers in, either onto our Facebook page, onto the events page, or you can email win@learnextra.co.za. You can SMS 083 448 8810, and you can also enter on Peptex, and the group code is Learn Extra. And don't forget that code. That code is very important, guys. And what you are winning are these awesome CDs, 3 of them, Mikasa, I think it's Soul Candy, and an awesome mindset book, as well as a t-shirt. But before we do that, let me just read a few things on the page. Anissa says, wow, lol, it's funny how during winter school we sat and watched mindset with our warm blankies and heaters on, and now for spring school it's hot and we've got the fans running. So I thought that was kind of cool and so true, because I'm feeling the heat in here. I just wanted to read. Nare says, who is the boss? It's Liberty, because they provide us with everything for free. Mahala. Thanks for Spring School 2012, and I hope we will return the favor by passing matric this year. Thanks, Channel Learn, and I hope my friends are enjoying as well. So now we're going to get to a question. This one is from Rory Sung. And Rory Sung, I love your questions because they are always so good. And I think that the other mindsets are probably wondering the exact same thing. And that's what Tamlin and I were saying. So, Tamlin, this is what Rory Sung wants to know. She says, what is the difference between a point of contact and a point of inflection?
Okay, right. Let's have a look at this quickly. If I draw a cubic function, let's just leave that for now. We're going to come back to that in a minute. If I've got a cubic function, that very roughly would look like so. Okay. If I've got a tangent to that function, anytime a line touches your graph at one point, regardless of where that point is, the point where your graph actually, your tangent and your graph touch each other, those are your points of contact. Okay, that's where the tangent and the graph touch each other at that one point. A point of inflection, however, is the point on your graph where you change from basically having a concave up to a concave down graph, okay? And where the gradient of your function, where the gradient of your tangent goes from being positive to negative. And the way we work out our point of inflection is we always work out our second derivative, and we let our second derivative equal to naught. So that is the difference between your point of contact and your point of inflection. Okay, so I hope that answers your question, and that's what you will do with your point of inflection in function questions like that. Okay. Right, let's go back to our previous question, and let's just get rid of these lines. Okay. All right, we had a few type problems in the previous question, so let's just clarify. It's definitely 2x cubed. I've got a px squared. I've got a qx minus 7. And the point of contact that we have now worked out is, this is our point of contact, is going to be 1 and negative 3. Okay, so now what they've asked me to do is find the value of p and q based on all of this information over here. As soon as you're being asked to find two variables, I'm sure you guys know it by now, that we're going to go along the route of a simultaneous equation. Okay, so I need to approach this from two different perspectives, and I need to try and establish two different equations that I will be able to solve simultaneously. Okay, now the first way we're going to look at it is this. Your point of 1 and negative 3 is a point on your f of x function. Okay, so if you've got a point that is sitting on a line, we can take that point and substitute it into the equation, all right? So that's going to be the first thing we're going to do. I'm going to take my f of x. No, it's actually g of x. Take my g of x function. So used to calling it f of x. Okay, and we're going to substitute it in, which means that the y value is getting replaced with negative 3. The x values are getting replaced with 1. Okay, I've got a q, that's going to be 1 minus 7. And we're going to have to simplify this, so therefore 1 cubed is just 1, and 2 times 1 is just 2. That's going to stay just p. That's just q, and that's negative 7. And let's just, if I've got 2 minus 7, that's obviously negative 5. And if I bring my negative 5 over, it's going to become positive 5, and that gives me p plus q. So we're sitting here with a positive 2 is equal to p plus q. And for now, that's going to have to be equation 1. Okay. Where else can we find an equation from here? Okay, going back to what we started off the show saying is that a derivative is the gradient of your tangent, okay? So think about that. If I work out the derivative of my g of x function, I can make that, because that is equal to the gradient of your tangent. Now, the gradient of my tangent, we've been told, is 5. Okay, that's the equation of my tangent, and that m value is equal to 5. So therefore, we know that the gradient of my tangent, so if I work out my derivative is going to be equal to 5. Okay, so that's going to be our next working out. I'm going to do it on the side here. So g dash x is equal to, let's just see if we can put it up in front of us here. Right, 2 times 3 is going to give us 6x squared. I have got a plus 2px. I'm going to have a q, just a plus q. And remember, when we're working out the derivative, the constant term at the end falls away, so 7 will no longer be there. And what we know we can do is make that derivative, that gradient of our tangent, equal to 5. So 6x squared plus 2px plus q, and that's all equal to 5. And can we simplify here? Okay, now, in fact, hang on, we've just hit ourselves a little brick wall here. There's too many variables, okay? I'm solving for an x, a p, and a q. Not good, okay? However, what did we know about the value for x at the point where the tangent touched the cubic graph? The value for x was 1, so we are allowed to sub that in, okay? So therefore, where we have an x, we are going to substitute 1 into the equation. Okay. That then simplifies to give us what? We've got 5, I've got 6, I've got 2p, and I have got plus q. And if I bring my 6 over, we'll have negative 1 is equal to 2p plus q, and I'm going to call that equation 2. Okay, now what works quite nicely here is that both of my equations have a value of q in them. So what we're going to do is I'm going to rearrange each of my equations to make q the subject of each equation. And once I've done that, I can essentially say, well, if both the equations are equal to q, then I can make the 2 minus p equal to the negative 1 minus 2p. So therefore, 2 minus p I'm making equal to negative 1 minus 2p. And what's that going to do? When 2p comes over, it becomes positive 2p, and positive 2 minus 1 leaves me with just 1p. I've got negative 1, and when my 2 comes over, it becomes negative. So we've landed up with a value for p of negative 3. Okay. And now that you've got a value for p, we can substitute it back into either equation 1 or equation 2. It doesn't matter. Okay, so let's put it back into equation 1. So what we're going to do is sub p equals negative 3 into equation 1. Okay, so therefore what we have got is 2 minus negative 3, and that's going to be equal to my value for q, and that would land up with 2 plus 3, which is 5, and that's the value for q. Okay, so those were the values for the p and for the q. But again, grade 12s, it's great to get the answer, but what we're really impressing on you is the process, okay? If you're having to find 2 missing variables, as you did over here, what we had to do was work through it. We had to find 2 equations that we could work with based on the information given. The first equation, let's just make sure we know. The first equation came from taking the point of contact and saying, well, that point is sitting on your line. So because it's on your line, we're going to take it and substitute it into the formula, okay? The second equation it was a little bit more interpretation because we had to be clear on the fact that a derivative is the gradient of your tangent. Now, because we actually had the equation of our tangent, I had the gradient, and your gradient was 5. So therefore, what we had to interpret from that is that if I were to work out the derivative of my g of x function, I could make that derivative equal to 5. So can you guys see how important it is that we understand what we're doing when we're working with a derivative? Because that's how we're going to be able to interpret questions later on and actually work things out based on that information. So always remember it. It is really important, and that would be a really good example of how we apply that information. Okay, grade 12. I hope you guys are all staying with us, and we're almost about to answer that challenge question, so I hope everyone's ready. But before we do, I just want to have another look at one more question over here. This is still a cubic function, but what's nice about this is that it's actually been phrased in a slightly different way. Okay, we all know that at the end of the day, they're asking us the same thing. They've just made it look slightly different. And because it looks slightly different, everybody has a moment of panic, but you mustn't. Okay, you just got to take a second to read carefully, think about what it is that they're saying, and you'll realize that it's very much along the lines of what you already know. Okay. Let's see what they've told us. They've told us that I've got a cubic function which has the following properties. Okay, so now let's see what they've said over here. Again, let's just watch out for typos. We want the f in front over here. All right, f of a half is equal to f of 3, which is equal to f of negative 1, and that's all equal to 0. Okay, now let's think about this for a second. All of these numbers have all replaced the value for x, haven't they? Okay, in the first one, x got replaced with a half. In the second one, x got replaced with 3. And in the third, x got replaced with negative 1. And, okay, so do you guys agree that all of those values are then essentially x values, all right? And the y that each of them were equal to was equal to 0. Now, how do we interpret that? If I know that my y value is equal to 0, the point that we are working with has got to be your x-intercept, okay? Because every time x is equal to 0, that's where your line is crossing your x-axis. So what can I interpret from this? All of these values here, a half, 3, and negative 1 are all x-intercepts. Okay, so that's pretty interesting. Okay, and I hope you guys understand that. So every time y is equal to 0, whatever the value for x is, that is an x-intercept. Then they say that f dash 2, now we know that that's our derivative, is equal to f dash of negative a third, and again it's equal to 0. Okay, let's think about it for a second. What happened when my derivative was equal to 0? When we were working with graphs, what did that give me? I hope you guys were saying to me it's giving you your maximum and your minimum. It's giving you your turning points, okay? So therefore, when your derivative is equal to 0, we have got our turning points. And remember, another way we could phrase that is your stationary points. Okay, so those are my turning points. Okay, so that's what I've got so far. And finally, we've been told that f decreases between the values for x of negative a third and positive 2. Okay, so we've now got to take this information and we've got to draw a picture of as an accurate a picture as possible with what they've given me over here. So let's see what we can do.
Let's go to an ad break before we start drawing that, I reckon.
Already?
I know. That way I can give myself a little bit of a stretch and a relax. Guys, the competition is now closed. Now we can actually start sifting through, see who the winner is, so we can announce it at the end of the show. Don't forget to keep those questions coming on our Facebook page, facebook.com/learnextra. We'll see you now after the break. Hi guys, welcome back. We are moving into the last 15 minutes of the show. We will be going over a few more questions as well as announcing who the winner is and going over the competitions question, of course. I just want to give a big shout out to all of you guys that are watching at PC Training. I hope that you guys are all enjoying the lesson and you're having lots of fun. Let us know if you're watching, and I think that's so awesome. All of you guys together watching Mindset Spring School. Without further ado, I think let's get straight back on the horse.
No time to waste.
No time to waste. Tamlin, take it away.
Okay, thank you so much. Right, so what we established was we had 3 x-intercepts, the first being -1. I then had another x-intercept of a half and 3. Okay, remember that was what we said in the very beginning, your half, your 3, and your -1. And we had turning points where x was 2 and where x is -1/3. And finally, that it is decreasing from -1/3 to 2. So from -1/3, what I'm going to do is a dotted line through -1/3 and a dotted line through 2. Okay, so all I know is that my function from this point to this point, okay, wait, hang on, it's got to go through, let's just draw it. Okay, it's got to go through here, it's got to intercept my x-axis at a half, and it's got to be decreasing up to that point over there. So this information is telling me that between these 2 dotted lines I have a decreasing function, which obviously would then look like so. So to complete it, then my other side would have to be increasing through the x value of -1. It was decreasing between -1/3 and +2. And from 2, it was then increasing again through 3. And that would then be the picture of all of that information that they gave us earlier. So a nice way of interpreting it. And as I said earlier, it's not asking anything different. It's just being asked in a slightly different way. So it's always worth looking at that so you don't get a fright when you see it in an exam and you've never seen it before. So look out for questions like that and go and practice them. I know one of the mindsetters has sent us in a question asking us about the diagram of a derivative. Okay, so this is a really good question to, I think, finish off with, because it's actually quite tricky and it does deserve a little bit of attention. So let's have a look at what it actually is all about here. Okay, this diagram over here is not my f of x. This diagram over here represents my derivative, my f dash x function, okay? Now think about this logically for a second. If f of x is a cubic function, all right? If I find the derivative of f of x, the derivative would be equal to 2x squared plus 2bx plus c. So do you guys agree that what we land up with now is a quadratic function, okay? So the derivative, if we were to draw a graph of it, of a cubic function, will always land up looking like a parabola, okay? And that, I hope, would make sense to you guys, okay? So because it's a parabola, the first thing they've asked me to do is to work out the equation of this function over here. Now this takes me back to just normal functions. If I was having to find the equation of a parabola, I would say, okay, I've got 2 x-intercepts, I've got a -1, and I've got a 5. So we're going to have to start by saying y is equal to a. I'm going to have to say x minus x1, that's my first root, and x minus x2, which is your second root. Let's substitute those in. So I've got x minus, remember 2 negatives will make positive, and I've got x minus 5. Right, now again, what we're going to do is look for another point. That other point there is, remember, the coordinates of x is 0 and y is 15. So therefore, I will have 15 is equal to a, and these are now zeros. 0 minus 5. And that lands up giving me, what do we have? That lands up giving me an a, and I get a -3 times by 1, which is just -3. No, 5, sorry, 5. I'm doing the sum in my head already. And that 15 divided by -5 is -3. That's our value for a, okay? Subbing that back into my equation over here, we would say that y is equal to, I now have -3. I've got x plus 1, and I've got x minus 5, okay? And quickly we're going to FOIL that out, which is going to give me -4x minus 5, which lands up giving us -3x squared, plus 3 times 4 is 12x, and 3 times 5 is 15, okay? Right, that equation represents your derivative. Very quickly, how do we now take that and go back to working out our original function, okay? Remember, your rule was that we had to, if I took if I had 2x to the 5, just very quickly to work out the derivative of that, we said 2 times 5 was 10, and I subtracted 1, so I landed up with 4. To work backwards, okay, if I actually have the derivative already, I do the reverse process, okay? So I start by adding 1 to my exponent, which is going to land up giving me 5, and I divide my whole by that exponent. So I land up with 2x to the 5. Okay, so I've done the reverse process. So let's do the reverse process and work out what we are going to get over here. And very quickly we land up with, if I add 1, I'm going to land up with 3 divided by 3. That's going to be negative 1x cubed. If I add 1, 2 divided by 12, 12 divided by 2 is 6x squared. And this over here would have to just be x to the naught. So if I added 1, it would land up being 15x. That would be your f of x function, the original f of x function. Okay? From here, if it's above your x-axis, you know that that's where your graph is increasing, and where it's below it is decreasing. These points over here will represent the turning points of your original graph. Why? Because that's where your derivative was equal to naught, okay? So my 2 turning points of my original function are going to be at the point where x is negative 1 and 5. So very quickly over here, I don't want to leave us a short time. The turning points are going to have to be where I had x was negative 1 and x is 5. So negative 1 and 5. And again, I'm going to do a dotted line through them because that's going to determine where we're going from positive or increasing to decreasing, okay? Between those two values over here, between negative 1 and 5, my graph was, we had positive function over there. So therefore, what we're going to say is that between these two values, I'm going to have an increasing function. And then from the other side, from the two other sides, it would be decreasing. So as a very rough sketch, that's what your cubic function would look like from the derivative. Okay, so remember that derivative represents what your derivative is, and where the derivative is equal to naught. So in other words, the x-intercepts of your derivative work out to be the turning points of your original function. Okay, again, go and practice those, guys. It could very well come up. Okay. Right, I think it's time to now have a look at our challenge question, and let's see who landed up getting the answer correct.
Do you know we actually do have a winner, which is really, really exciting.
Fantastic.
Yeah, I'm so excited, and I know this person, so I'm even more excited. I do know, I think I saw here, there were lots and lots of different answers. So I think it's going to be really interesting and exciting to see what the actual answer is. Okay. So let's work on it. And guys, if you have any questions, now is the time to post them. Get busy.
Let's have a look. Before I actually tell you what the answer is, let's work through it and you can see what the answer is going to be. The derivative function of f is f dash x equals x squared plus 2x minus 3. Just remember, the derivative function will always be quadratic where your original function was cubic. Okay, so just remember that that will always kind of fit together. So that's our function over there, and they're asking us for which values of x does the function have a turning point that is at a local minimum. So we're looking at the original f of x function, and where is it going to be at a minimum? Let's have a look at this. Remember, when we're working with turning points, we would say let the derivative equal to 0. Okay, so we have the derivative over here. So let's take the derivative equation and let's make it equal to 0, because again, that's theory. That's what we know the turning point does in our cubic functions. So we are going to let the derivative equal naught, which means I've got x squared plus 2x minus 3. And let's factorize what we've got here. Okay, we've got our x and our x. We've got our 3 and our 1. To get a positive 2, I would have to have a plus 3 and a minus 1. Okay, that's giving me 2 answers for x. I'm sitting with a negative 3 and a positive 1. Okay, now the problem is, how do we determine which one of those is the minimum? We're looking for the minimum over here. Now, grade 12, there is more than one way to actually go about this. Okay, we can substitute if we know what the original cubic function is. In this particular case, we don't. Okay, so we don't have the f of x function, so we can't go about it that way. Another method is inspection. Now, inspection means without working out, just by means of actually looking at what you've got, find the answer. Okay, and the third way, which if we have a minute I'll give you guys an explanation of, is we can use something quite handy called a second derivative test if you've learned it at school. Okay, so let's have a look here. I can see that this is going to be a positive, that's a positive parabola, okay, which means that it's going to be an increasing, it's going to be a positive cubic function. So if I were to draw a very rough sketch of a positive cubic function, it would start by increasing, it would then decrease, and then it would finish off by increasing. Okay, so what I can see just by looking at this is that if this was the x-intercept and the x-coordinate of the two turning points, this turning point would have an x value of -3, and this point would have an x value of +1. Now, I'm sure just by looking at the diagram, you can quite clearly see that which one is giving you the minimum? +1 is getting you to your minimum. Okay, so guys, if you said that your answer was 1, you are absolutely correct. Okay, absolutely 100% correct. Let me quickly show you the second derivative test. So if it's something you have learned at school, you can just go over it. If our first derivative was x squared plus 2x minus 3, x minus 3, that was our first derivative, what we can go about doing is working out our second derivative. Okay, that means I'm going to land up with a 2x plus 2. What we are then going to do with that second derivative is we take my two values for x that we're working with and we sub it into the second derivative. So we substitute 3 in, and then we're going to substitute 1 in. Okay. And by doing this, this is the story. You're going to land up with an answer that's positive and an answer that is negative. The one that is positive is always your, I'm multitasking here, is always your minimum, and the one that is negative is actually always the maximum. So it works in reverse in terms of sort of your logic. The negative is the minimum, the negative is the maximum, the positive is the minimum. So therefore, because I had a positive value over there, I know that that gave you my local minimum. So there we go, guys. That's what your answer was. I certainly hope if you had a problem with that, that you can quite easily see how it is we go about finding which is the minimum and which is the maximum. Very keen to know who won.
Okay, this is where I need the drum roll. If only I had brought drums in. Okay, so now the winner of this challenge question is Sidonia. And Sidonia, well done, lady. You are always on the page. You are also always asking questions. Apparently, you sent in so many answers that you almost clogged up our system completely. So well congratulations. And please, will you send your details to win at learnextra.co.za. Congratulations. And here's a little clap from all of us here.
And I actually must say that I've had a look through the book that you've just won, and it's awesome. It's really, really helpful, and it's going to really give you a lot of worthwhile tips and a lot of help. So well done.
So we've got 1 minute, and I want to squeeze in a quick question. And this one is from Anissa. And Anissa asks, thought we equate the derivative to 0 to get the minimum. Please help.
Okay, the only time when you equate your derivative equal to 0, you're finding your turning points, okay? And with a cubic function, there's always 2 turning points. So the problem is that if you let your derivative equal 0 and you land up with 2 answers for x, as we did over here, the challenge then is to understand which one is the maximum and which one is the minimum. So yes, you are letting your derivative equal to 0, and that's absolutely right. But you need to understand that that will give you both turning points. So to then understand which one is the minimum or the maximum, as I said, you can draw a rough sketch of what your just a normal positive cubic equation would look like. If you had a negative derivative, you would have a negative cubic function. And in fact, a negative cubic function would go the other way. So it would go in this direction, in which case this would be the minimum and that would be the maximum. So you just need to understand that, and that should answer your question.
Okay, awesome, guys. We've had such an awesome lesson. Don't forget that Maths Lit is on later, and also these shows are repeated again tonight. So if you're watching this done tonight, it's on tonight. See you guys later. Had an awesome first show. Bye.